The domains of chemistry. Chemists study and describe the behavior of matter and energy in three different domains: macroscopic, microscopic, and symbolic. These domains provide different ways of considering and describing chemical behavior. Macro is a Greek word that means large. The macroscopic domain is familiar to us. It is the realm of everyday things that are large enough to be sensed directly by human sight or touch. In daily life, this includes the food you eat and the breeze you feel on your face. The macroscopic domain includes everyday and laboratory chemistry, where we observe and measure physical and chemical properties such as density, solubility, and flammability. Micro comes from Greek and means small. The microscopic domain of chemistry is often visited in the imagination. Some aspects of the microscopic domain are visible through standard optical microscopes, for example, many biological cells. More sophisticated instruments are capable of imaging even smaller entities such as molecules and atoms, see Figure 1.5b. However, most of the subjects in the microscopic domain of chemistry are too small to be seen even with the most advanced microscopes, and may only be pictured in the mind. Other components of the microscopic domain include ions and electrons, protons and neutrons, and chemical bonds, each of which is far too small to see. The symbolic domain contains the specialized language used to represent components of the macroscopic and microscopic domains. Chemical symbols, such as those used in the periodic table, chemical formulas, and chemical equations are part of the symbolic domain, as are graphs, drawings, and calculations. These symbols play an important role in chemistry because they help interpret the behavior of the macroscopic domain in terms of the components of the microscopic domain. One of the challenges for students learning chemistry is recognizing that the same symbols can represent different things in the macroscopic and microscopic domains. And one of the features that makes chemistry fascinating is the use of a domain that must be imagined to explain behavior in a domain that can be observed. A helpful way to understand the three domains is via the essential and ubiquitous substance of water. That water is a liquid at moderate temperatures, will freeze to form a solid at lower temperatures, and boil to form a gas at higher temperatures. Figure 1.5 are macroscopic observations. But some properties of water fall into the microscopic domain, what cannot be observed with the naked eye. The description of water as comprising 2 hydrogen atoms and 1 oxygen atom, and the explanation of freezing and boiling in terms of attractions between these molecules, is within the microscopic arena. The formula H2O, which can describe water at either the macroscopic or microscopic levels, is an example of the symbolic domain. The abbreviations G for gas, S for solid, and L for liquid are also symbolic. Figure 1.5a. Moisture in the air, icebergs, and the ocean represent water in the macroscopic domain. B. At the molecular level, microscopic domain, gas molecules are far apart and disorganized, solid water molecules are close together and organized, and liquid molecules are close together and disorganized. C. The formula H2O symbolizes water, and G, S, and L symbolize its phases. Note that clouds are actually comprised of either very small liquid water droplets or solid water crystals. Gaseous water in our atmosphere is not visible to the naked eye, although it may be sensed as humidity. Credit A. Modification of work by Gorkozk/Wikimedia Commons,